Hey, it's Mr. Win, and let's win some chemistry. This is Colligative Properties Part 2. Make sure you watch Part 1 if you haven't done so already. This part requires some math, so you'll need your pen, paper, calculator out, and let's get right to it. A few things I want to point out before we start going into the math. On your notes, you're given the equations for boiling point elevation and freezing point depression, so it's right there at the top of my screen. It says delta TB equals the number of ion particles times Kb, which is a constant. It's called the boiling point constant, times little m, which stands for molality. And then likewise for freezing point depression, the only thing that's different is instead of saying Tb, it says Tf, which is the change in freezing point temperature. So the F stands for freezing point. And then for K, the constant, it's K sub F. Okay, so K and then little f. And in your book, okay, so in chapter 15, there's two tables, but I copied it here. These are the tables for your freezing point and boiling point constants, but you really only have to worry about water because in this class, when we're dealing with solutions, we mainly work with just water as a solvent. So everyone knows that water boils at 100 degrees Celsius and then water freezes at 0 degrees Celsius, and then the only two constants that you have to memorize are right there at the top of the table. So for boiling point constant, it's 0.512, and then for freezing point constant, it's 1.86. Let's go over this problem together. This is number 33 on page 475 of your textbook, and it reads, what are the boiling point and freezing point of a 0.625 molal aqueous solution of any non-volatile, non-electrolyte solute? So if you recall from my salt sugar screencasts, a sugar solution is non-electrolyte. So that's just a fancy way of saying a sugar solution. So that means for number of ion particles, I will plug in a 1. And I know that it's 1 because glucose does not break up into like a bunch of like individual ions. And you could find it there in the lower left of the screen. So that's why I plug in a 1. For Kb, I'm going to plug in 0.512. That's the boiling point constant. So for water, I'm going to plug in 0.512. And then for molality, this number is actually given in the problem. I'm going to plug in 0.625 in a moment. Okay, so it's very similar to molarity, except instead of liters of solvent, it's going to be kilograms of solvent in the lower right of that triangle. So I will plug in 0.625 right there. And then once I have all three numbers, I'm gonna multiply it, and we're going to get 0.32 degrees Celsius for this one. So that's how much the solution's boiling point temperature will change by 0.32. I'm going to add that to its original boiling point. You can see it highlighted there in red. Water boils at 100. So when I add the 0.32 to it, I get a total of 100.32 degrees Celsius. That's the new boiling point of water. So moving on to the next problem, the only difference is we're going to use TF and KF for freezing point. So again, the number of ion particles is 1, KF is 1.86, and then molality is still 0.625. So that means the freezing point temperature will drop by 1.16. I'm going to subtract this from 0 degrees Celsius, and we're going to get negative 1.16 for the new freezing point. Let's try another problem together. This one is 87A on page 485. Calculate the freezing point and boiling point of a 2.75 molal solution of sodium hydroxide NaOH in water. The answers are provided. Let's figure out what it is. We know the freezing point is going to go down. It's going to go below 0, but by how far? And we also know the boiling point will go up above 100, but by how far? So there's some math behind it. Let's figure it out. We're going to do the boiling point first. So for NaOH, I'm going to plug in 2, because if you look in the lower left of my screen, NaOH kind of resembles the molecule NaCl. It's going to dissolve into two separate ion particles. So that's how I know to plug in a 2 there. Next, I'm going to plug in for Kb. This is the boiling point constant. Again, it's 0.512. And then we're going to plug in for molality 2.75. This was provided in the problem. If they give you like grams of solute and kilograms of solvent, you would have to use a triangle and then solve for that number. We'll do that in the next problem. Okay, so we're going to Put this all in the calculator. Let's see what we get. And we're going to get 2.8 degrees Celsius. And we're going to add this number to 100. So the boiling point change by 2.8. So it's going to go above 100 because it's boiling point elevation. So the new boiling point of our solution is 102.8 degrees Celsius. The next problem is calculate the freezing point. So we're going to replace TB and KV with TF and KF. And again, because we're dealing with NaOH, it's still going to be 2. It's 2 ions. Sodium hydroxide breaks into 2 ions. And KF is going to be 1.86. It's in that table that's in the lower part of the screen. And I'm going to plug in 2.75 again for molality. That's the concentration of my solution. So when I crunch these three numbers, I am going to get 10.2 degrees Celsius. That's how much the freezing point will change by. So I'm going to subtract this from 0 degrees Celsius. My new freezing point is now negative 10.2 degrees Celsius. Okay, so again, this is known as freezing point depression. When I start dissolving stuff in a solvent, it causes the freezing point to go down. Let's do one last problem together. Number 86 on page 485. Calculate the freezing point and boiling point of 12 grams of glucose in 50 grams of water. The only thing that's different about this problem is they don't outright tell you what the molality is. So I'm going to circle it. We're going to come back to it. But for I, again, I'm going to plug in 1 because it's sugar. You can see on the lower left of the screen for glucose, plug in a 1. For KB, again, plug in 0.512. That's highlighted in red in the lower portion of my screen. So now I need to figure out what the molality is. I'm going to write down 12 grams C6H12O6, and this is dissolved in 50 grams of our solvent, which is water. So I'm going to draw the triangle again, and this is just like the molarity triangle. The only difference is you just change grams of H2O into kilograms of H2O. So let's start with the solute first. So our solute is the sugar because that's the thing that dissolves in the solution. So I'm going to have 12 grams of C6H12O6, and I'm going to find my way into the triangle. So I'm going to convert grams of glucose into moles of glucose by dividing by its molar mass, which is 180. Okay, so the grams will cancel out. I'm left with moles, and the number that I'm going to put in at the top of the triangle is going to be 0.06 moles of glucose. There's just one final number I need to work with. I need to change 50 grams into kilograms. So I'm going to divide this by 1,000, and it turns out it's going to be 0.05 kilograms. So now I take 0.06, divide by 0.05, and that will tell me what the molality is, that little m that I circled. And the molality is going to be 1.2. And now I plug it back into the equation. That's the final piece of the puzzle that I needed. So I'm going to go 1 times 0.512 times 1.2, and that will tell me the new, or the change in boiling point is 0.1 or 0.61, and I'm going to add that to 100 degrees. So my final answer is 100.61 degrees Celsius. That's my new boiling point. Let's have a look at what you need to turn in. These are the notes that came along with parts 1 and 2. Part 1, I covered this top section. Part 2 was all of this down here. So this was the actual math that you had to do for this lesson. Part 1, okay, has 6 problems, and it's all very straightforward. Just make sure you listen to that screencast. Part 2, I did this problem in yellow, this problem, and this problem, half of this problem here. So you still had to calculate for the freezing point in problem 86. And there's also 2 more practice problems. So these you have to show the work for. You can handwrite it, you can type it up, and then just make sure you resubmit this on Google Classroom. That concludes this screencast. Make sure you tune in next time for Win Chemistry.